Okay guys, this is lesson 4, numbers raised to the 0th power. It is on page 35 of your workbook. You have to skip a couple of sprints that I'm not sure that we're going to do because of virtual. But this lesson is referring to the 0 exponent rule. So it's another rule that we're going to be talking about for exponents, but the whole lesson kind of just talks about the different ways that the rule works, and it's very algebraic in nature, so it might be super confusing for you. So really the thing that you want to know is, and on the page right next to it is blank, I would write this. The 0 exponent rule says that for any positive number x, we define x raised to the 0 power equal to 1. Or any number raised to the 0 power is equal to 1. Now you might think that it is equal to 0, but that is not true. It is equal to 1. And here's an example of why it works using the quotient rule. If you have y to the 12th divided by y to the 12th, we know that with the quotient rule, that is going to be equal to y to the 12 minus 12, right? Because the bases are the same, you just subtract. And then that is equal to y to the 0 power. Now how that proves what I was saying up here is that if you divide any number by itself, it's 1. We know that. That is the identity rule. And if that is equal to 1, then this is equal to 1 because they are all equal. So y to the 0 power, x to the 0 power, any base to the 0 power is going to be equal to 1. So that's what you want to know. Now let me go over lesson 4. It starts off with showing you that we have shown that for any numbers x, y, and any positive integers m and n, the following holds true. So you have the product rule, you have the power rule, the expanded power rule. I added the quotient rule, and this is an expanded power rule too, but it's using quotients, so I just put it there. Just ignore that little dot there. So exercise 1 says, list all possible cases of whole numbers m and n for identity. For identity 1, okay, for this one. More precisely, when m is greater than 0 and n is greater than 0, we already know that 1 is correct because that's what they said up there. What are other possible cases of m and n for which 1 is yet to be verified? So like case A, if m is greater than 0 but n is equal to 0. For case B, if m is equal to 0 and n is greater than 0. For case C, if m is equal to n is equal to 0. That's one. Those are 3 cases that we're going to check in exercise 2. If I were you, I would just copy these down. Like I said, the big major thing you want to know is the thing that I just went over, is the 0 exponent rule. The rest of this is just kind of proving the rules. Okay, so exercise 2, you have for case A, and we're checking that each of these equations is correct. So for case A, if the equation, right, is this equation, boop, for number 1, but we're replacing it for m is greater than 0 and n is equal to 0. So that n is now 0. And we're saying, is that going to be true? And we can say yes, because x to the m times x to the 0 is x to the n times 1, because anything raised to 0 is 1, which is x to the m. Okay, so do you see what we're doing? We're just kind of proving the 0 exponent rule in many cases for which possibly we don't just have all positive integers, but we have other types of numbers involved as well. Okay, case B. So we have x to the 0 times x to the n, and this I'm using this, but I'm replacing it with these. So now m is 0 and n is greater than 0. So that's x to the n, but now m is 0. And so it will work for the same reason as that worked. Case C, I m and n are both 0. So now we just have x to 0 times x to 0 is equal to x to 0. Yes, that's true because we know that those are 1, and 1 times 1 is going to be 1. And so all of them work. Okay? For exercise 3, you do the same thing, but we're checking equation 2. And this one's a little more complicated, so we're checking this equation. We're checking it, but we're plugging these in, case A, case B, case C. So you can see case A is now x to the m raised to the 0 power. Is it going to be equal to x to the 0 times m, or m times 0? And we can say yes, because x to the m is a number, and a number raised to a 0 power is 1. 1 equals x to 0 equals x to 0 times m, so the left side is 1, and the right side is also 1, because x to the 0 times m is going to be x to the 0. Anything times 0 is 0, and that's also 1. Case B is x to the 0 raised to the n equals x to the n times 0. And saying yes, because by definition x to 0 is 1, and 1 to the n is 1. The left side's 1, the right side's 1. So that works. And case C, I'm just replacing m and n with 0, if you recall. So we're seeing if this works, and yes, by definition, if you have anything to 0 power that's 1, it's going to be 1 equals 1. And exercise 4. Do the same thing with equation 3. Equation 3 is the expanded power rule, so I'm going to be using that expanded power rule and replacing it with case A, case B, and case C. Case A is going to be, if I'm replacing, case A is, right, n is 0. So if n is 0 there, so case A, x times y raised to 0 power is equal to x to the 0 power, y to 0 power. So yes, because 1 is 1. 1 equals 1, right? And 1 times 1 is 1. Case B is also going to work. Since n is already greater than 0, we know it's going to work. It's going to be valid, and the same thing with case C. Okay, so those are just basic, not basic, those are very complex examples of the 0th power, numbers raised to the 0th power, and how they work in math, excuse me. So, what is next? Here's an exit ticket. You can hold off on that for now. The actual homework helper is doing more example-y problems, like the first one I showed. So it's not like you're going to have to show complexities like this lesson has shown. You're just doing examples of using the 0th power, okay? And the problem set, which will be on assessments, and it's also here if you wanted to work out problems here. And assessments will be on Google Classroom. All right.